Welcome, everyone. Today, we'll talk about building machine learning pipelines with Kedro and Vertex AI on Google Cloud Platform. My name is Michał Bryś, and I'm a machine learning engineer here at GetInData. My responsibilities are mostly covering the area I will be talking about today, and about the exercises we will do today. We will be talking about machine learning operations. We start with some introduction, then we do some introduction to Kedro, so it will be the first exercise, and the second exercise will be to run your MLOps machine learning pipeline on Vertex AI. I will share the links to the code labs descriptions with you, just if you would like to follow the instructions, or maybe you would like to do that exercise later on your data, on your projects. So it will be some materials after the workshop. So this is the agenda for today. So let's get started from the beginning. Nowadays, you can see a lot of things on the internet about machine learning, and you may have some impression that the whole machine learning process and building machine learning model the whole thing is about to train the best model with the best score, with the best accuracy. So we've got a lot of competitions, you've got a lot of open source models followed by code. So you may have some impression that the whole job of data science teams and machine learning engineers is to produce the best model. But this is not exactly the truth, because the success of machine learning project is not only about training the best model, like we can get some impressions, but it's more complicated, because the whole fun starts with the best-in-class model. There are next steps with this. So after we get the idea for the model, we need to follow the process, because machine learning model has a life cycle. Fortunately, that process was explored by researchers way before the big data era, and the machine learning and data science terms get popular, because it was around 1996. So on top of that experience with the researchers team, a few big companies gathered in the consortium that joined forces to build a universal data mining framework called Cross-Industry Standard Process for Data Mining, and the acronym is CRISP-DM. So that process, that framework, explains the machine learning model life cycle. And you can see that before we start modeling, first we need to do business understanding. Then we need to understand our data, and when we are sure what we've got on that data and what data issues could be inside of the data set, we need to prepare that data. And you can see the fourth step is modeling. So this is not the first, but the fourth step. When you train a model or a series of models, and you will decide on which is the best for you, then you should do the model deployment, and then you should evaluate the results. And this is not the end of the cycle, because you can see the feedback loop between the results evaluation and the business understanding, because sometimes and quite often the results from the successful machine learning project will surprise you, or will give you some idea to improve your business, and probably you will follow the next iterations of that whole cycle. So to summarize it, machine learning is a process. It's not only the one-time machine learning model training. And when it comes to the details, the implementation of machine learning projects contains much more elements than only the machine learning code. This is quite popular slide from the well-known white paper on the data science and machine learning industry. So we can see that the machine learning project contains not only the machine learning code, but the whole series of components to make available data for machine learning model and to make some infrastructure for that machine learning model, for example, serving. So we can see that the ML code is only the small portion of the whole project. We've got also some components needed for data collection, for some feature extraction, for data validation, for machine learning model serving infrastructure, even some infrastructure for model monitoring. So the machine learning model code is only small part of the whole process. So you can see that we've got a lot of resources to train machine learning models, but we also need more things to provide the infrastructure and the environment to deploy that models to the production environments. And to address that needs, the new culture of MLOps arose. MLOps is the shortcut from machine learning operations, and MLOps is the set of practices that aims to deploy and maintain machine learning models on the production environments on the reliable and efficient way. The main idea is to join the best parts of the software engineering, DevOps, data engineering, and machine learning to create good environment to build machine learning models. And you can also see that MLOps is an interdisciplinary field because it lives on the intersection of machine learning, data engineering, and DevOps. MLOps brings the culture and practice of the way of thinking. When we train machine learning model, we should keep in mind how we will deploy this model, how we monitor this model on the production environment. So this is the theory, but when it comes to the practice, you may think about, okay, so how my company, how my organization is mature on the MLOps adoption field. So fortunately, we've got also dedicated frameworks to evaluate your company and your culture in terms of the MLOps maturity. This one example framework comes from Google. And Google proposed the 3 levels of MLOps maturity. So on the first level, data science and machine learning models are machine learning models. Training is the manual process. So there is no automation. Data science teams train and build models manually on their laptops, on their local machines, sometimes on the virtual machines on the cloud. But there is no automation, no such thing like CI/CD. The whole process is the manual. It works in many cases. It allows you to evaluate the value of the machine learning models, but when you want to do something more and something better in the maintenance terms, you need to make a move from level 0 to, for example, level 1, which is about the machine learning model pipeline and the automation around that model. So this step contains to train your machine learning models using pipeline. It enables you to do rapid implementation. It enables you to do continuous training. So it solves many practical issues. And then when you are ready with the level 1, you may make a next step to the level 2, which is about CI/CD and pipeline automation. So it's not only about model training, but this level 2 is also about model deployment on the production, model monitoring, and, for example, triggering the retraining of the model when the model performance on the production environment breaks some threshold. So this is also the theory, but the practice is about, it's difficult on the production because even with that knowledge, with that frameworks, with that definitions, companies are still struggling with quick deployment their machine learning models on production. So here is the chart from the research survey from the last year called Trends in Machine Learning, and you can see that only 11% of organizations can put a model into production within a week, and the rest, like 60%, takes a month or longer to do this. So we can see like we've got tools, we've got theory, we've got knowledge about this, but the practice is that still it takes a long time to put the model from the data science team to the production level. You see that it's really complex thing. Today, I would like to give you some practical tips how you can change it if your company also struggles with that process. So today we will talk about and you will see some practical tips how to make that time to market of your model faster than you've got now. And the reality is that there are some challenges that MLOps tries to solve. And here are the questions I hear quite often from the data science teams I'm implementing MLOps solutions for. So, for example, I can hear that why my model has lower performance on production than on the laboratory environment. That the model degrades over time. There are like considerations like, can we trust our models? Another thing is like, what if we want to serve 100 times model predictions than we've got now? We've got concerns. Okay, the model is great, but we train it on our laptops, so it's difficult to deploy it to the cloud services, for example. Sometimes there are like concerns about can we understand and explain our models? So these are real life questions and real life challenges which MLOps tries to address. There are names for that practical challenges. You can see like that questions we can group under the training serving skew or data drift challenge. For the trust, you may think about the reproducibility and model monitoring. For the explanation, you will see the whole group of techniques to provide the explainability of models, and you can think about also the infrastructure and the scalability. The whole thing of MLOps is also to address that challenges. So to solve that real life problems, you need to make like step from the level zero of the MLOps maturity to level 1, and even better to level 2. When you are struggling with the problems on the level 0 and you want to do like next step, you should consider the MLOps. To use some MLOps framework, there are many MLOps frameworks. We at GetInData, we recommend the Kedro framework. The discussion about the framework selection is like a separate story, but this is one of the best solutions in class from our experience and from many success projects with our clients. So Kedro is the MLOps framework. And why we recommend that framework? So Kedro provides code structure for machine learning projects. So it makes easier development and teams collaboration, because you can imagine like how to manage like many machine learning projects within large organization. If you've got the common standard for that, it's really easy to understand and even understand the code and even collaborate between the teams. Also, Kedro framework introduces the ML pipeline concept. So it means that models trained this way will get increased reproducibility and faster time to market. Kedro is also really lightweight and open source framework, so you don't have extra dependencies. This is really important because Kedro itself is really lightweight and let's say thin layer of your ML project, because it provides only a few concepts but really fundamental ones. Also, Kedro works on multiple infrastructure providers, including cloud, because you may run your machine learning pipelines on your laptop, on your on-premise infrastructure, or on multiple cloud providers. So that pipelines becomes portable and mobile between different cloud providers when you use Kedro plugins. And what's important from the management point of view, there is no vendor lock-in. So you are not bounded to the one cloud provider. And also it's this is important step for the data science teams because Kedro supports any machine learning frameworks. Any means the only constraint is that frameworks should be in Python. So you can use TensorFlow, PyTorch, scikit-learn, and so on within the same MLOps framework. This is like really convenient for machine learning teams. But also, when we talked to our data science team, there are also some downsides for them. The first impressions of data scientists when they start to work with Kedro was that there is hard to start from scratch for newcomers. Also, you need to put some extra effort because you need another software framework to learn. Also, it was questions about and concerns about the setup environment and infrastructure at the beginning for cloud services. Data scientists also mentioned that there is too much flexibility because there are no hard constraints on the best practices and anti-patterns. So for one, it could be the benefit, for another one, it could be the downside. Also, data scientists mentioned that it was hard to collaborate within the team in the experimenting phase. But it was also connected mostly with the local development and the heavy use of Jupyter notebooks. So it was really hard to join results, for example, from two researchers. But also we will address that thing today. So these are like downsides and concerns for the Kedro project, but hopefully after the workshop today, you will see that there are easy solutions for that. So why Kedro? What is Kedro? So Kedro is an open source Python framework for creating reproducible, maintainable, and modular data science code. And the Kedro authors says that it borrows the best concepts from software engineering and applies them to a machine learning code. So this is the theory. And within that framework, we've got a few concepts introduced. So the machine learning pipeline is a directed acyclic graph. So this is the common term on the software engineering because we build our machine learning pipeline with nodes. We've got direction of the flow of that nodes, and we've got no cycles. So you should you should think about your pipeline like about directed acyclic graph. Inside of the graph, we've got nodes. So node is a wrapper for a Python function that names the inputs and outputs on that function. And this is the building block of the pipeline. We've got also pipeline, like the whole thing. So pipeline organizes the dependencies and the execution order of nodes and connects inputs and outputs. And what's important, like the pipeline will be executed on the order, not like you define this on the code, but previously it will be, build the graph of dependencies, the inputs and outputs, and it will be like the Kedro and executor of like runner of the Kedro pipeline will decide about the order of the pipeline steps based on the inputs and outputs. And the next thing which Kedro introduces is the data catalog. So this is the Kedro specific thing, and this is the registry of all data sources for the project it can use. Practically, it takes out the duties about making connectors to different data sources, different cloud providers. So it takes it from you, and it's built inside of the Kedro framework. Also, it's easy to switch, for example, the data source from BigQuery table to the CSV file on the Google Cloud Storage, and so on. So it's really easy and modular thing. And what's important in terms of the information security and the compliance things. So by default, the data catalogs are memory data sets. So they will disappear after the pipeline execution. So if you don't need to serialize your data between the pipeline steps, you can use just a memory data set. I know that it could be complex for the first view, but you will see this soon in practice. In addition to that Kedro concept, Kedro provides also the directory structure and the project structure for the to organize your machine learning project. So there is a place for configuration files which are separated from the pipeline code, and they are defined on the YAML file. There is place for data sources if you use local files and you want to, for example, export your model for serving. So there is a place, dedicated place for this. You've got place for documentation, for logs, for Jupyter notebooks, and the pipeline source code. So in the big picture, Kedro is the pipeline nodes, direct cyclic graph, data catalog, and the project structure. So we've got that 5 elements introduced by Kedro. And now there is a time for the first code lab. So what we will do, we will create our first machine learning pipeline with the Kedro framework, and we will run it on the local environment. So here is the link. Also, you can see that link on chat. This is the link to the code lab instruction. So if you like, you may follow my steps on this, or if you want to do this later, you may just keep it for the records and watch my screen. So now I will switch the window sharing to the code editor. There we go. So I've got open the code editor. This is the Visual Studio Code, and we will need the interactive terminal open. So first step will be to make the directory for our environment. Then we will install Python virtual environment, just to not interfere with our local file system, because we will install some Python packages, and I would like to do this on the virtual environment. So I just installed the virtual environment Python package. Then I will create the virtual environment for the workshop purposes. So you can see that the directory with the workshop environment was created on the file system. Then I want to activate that virtual environment, and you can see that now in my terminal there is an active workshop environment. For those who are using Conda, you may see also the base thing in brackets. So it means that now we've got activated both virtual environment and Conda. For the purpose of the workshop, I want to deactivate that Conda environment. So now I'm ready. I've got only virtual environment from the workshop active. So this is the default environment preparation. So now I would like to install Kedro framework on that virtual environment. So this is just pure pip install, and you can see that that Python package is installing now. This is the live demo, so hopefully it works. Yes, it works. And that's it. We are ready to create our pipeline. So we just created a virtual environment for Python packages. We installed a Kedro Python package, and we can start to create our first machine learning pipeline. This is a really simple thing, because Kedro framework provides something called starters. So starters are a project with some default data built in, with some machine learning model pipeline also included. So this is good to learn Kedro. So we may treat it as a template project for machine learning pipelines. So we will create a new pipeline, and we can do this using Kedro new and option starter called space flights. And this will trigger the tutorial for you to create your first machine learning pipeline. So the only thing you need is to provide the project name and hit enter. And then it will create for you the whole directory structure and the whole project. So we can see like this command created the folder called space flights, and here we've got the code for our pipeline. So now I will walk through the code, but let's allow to install project dependencies in background, because every Kedro project manages the project dependencies by the requirements text file. So here you've got a list of Python packages required to execute that machine learning pipeline. This is really convenient way for the portability, and also we will use it later just to install the same Python packages for the inside of the Docker container for the next exercise. But for now, we will just trigger so let's change directory to the space flights, and we will do pip install of our requirements text file. So it will take a few seconds. And now that Python packages are installing to the virtual environment. So we've got also a few seconds to walk through the code. So in practice, you can see that the Kedro project contains the configuration files with different environments. So this is also the big power of Kedro, that you may set up different configurations for your local execution and, for example, on your pipeline running on cloud. For example, for development purposes on local, you may read your files from the local file system on the CSV file, and on the production setup, you may just read your data from the BigQuery or Google Cloud Storage. So this is like really flexible thing of Kedro, and we defined this on the data catalog. So you may see that our data catalog looks like the YAML file when we've got defined a few input files called companies, reviews, and shuttles. Then we've got defined a few intermediate data we would like to save, for example, for the preview or for analysis of the intermediate data sets. We've got defined, for example, the Python pickle with the created model, and so on. So this is how data catalog works. And here we define the location of that objects on the local, on some external file system or some other data sources. You may also set up, like read for local development, use the local CSV file, and for the production you may create like another environment, and for production it could be the query for BigQuery to read your input data. So this is really flexible setup. So we've got configuration files, we've got the data structure. So here already we've got the CSV file included. After the first pipeline run, you will see that it will be, for example, trained model here. So we've got the whole data engineering concept with different steps and places for each step of the pipeline. You've got place for documentation, you've got place for logs, you've got place for Jupyter Notebook. There is also the integration of Kedro and Jupyter Lab here, but this is also another story. And you've got the source code of your pipelines. So you've got, for example, space flights, pipelines, and two sub pipelines you execute. But you will see this in the next step when we will visualize our pipeline. So now it's time to evaluate our pipeline on the graphic way. So we will use Kedro Viz. Kedro Viz, and enter. And this thing will open the web browser with the pipeline graph. So let's give it a few seconds to start. I decided to not opt into the analytics, and there we go. It should be in a separate window. So let's give it a second to start up. There we go. So inside of Kedro, we've got also web application to visualize your pipeline. So this is not connected with any execution, because we are evaluating only the pipeline graph and the pipeline nodes, and also the data catalogs. So we can see that the input data are on the three data catalogs. We've got reviews, companies, and shuttles. And for example, if you would like to see the details, so you can click on the node, and you will see that this is the type of data set. This is the CSV data set. You can see also the path to that CSV file. You can see that there are like two sub pipelines. First one is called data processing, and when you click on that pipeline, you can see that we've got a few pre-processing functions. So we've got the pre-processing for the companies input data. So you can see that this is the pipeline node. You've got the link to the actual Python file with that code. And you can see the inputs and outputs of that node. One nice feature is also that you may preview even the actual Python code for that pipeline node. So it displays the preprocessing code here. So it's easier to inspect your pipeline on the visual way. You may see also that there is data science pipeline, and there are two sub-pipelines defined there. On the active modeling pipeline, you've got the node to split data to the training and test data set. So we may also preview this thing here. So the input data set is split to the train and test. Then there is a train model node. There is a regressor, which is the actual Python pickle with the actual model trained, and there is also the data evaluation step. So here you can see that you just evaluated your pipeline, but it's not executed yet. So maybe now it's time to finally train our first model. So I will switch windows again to the code editor. I will stop my Kedro Viz, and now it's time to run your pipeline. So I will open also the preview for the catalog of data and models, and you can see that catalog is empty now. And now I will execute that pipeline. So this is there is a simple command called Kedro run. And now you can observe the progress of the pipeline execution. So first, it reads the data from the CSV file. There is also the example for the Excel data set. This is maybe more for the education purposes rather than the real life. And you can see that the whole steps of the pipeline are executed, and at the end there is a model trained. You may also you may even preview the model performance metrics because we run it, we print to the console the R square, which is 0.44, and for candidate this is for candidate model, and for the active model was 0.46. So we may observe that that model performance metrics there, and because we defined the model export in the data catalog to the local file system, so we've got models on the 06 models directory, and for example for regressor active, we've got also the versioning of the model export, and here we've got the actual scikit-learn model, which we can deploy to the other services for serving. Maybe one interesting thing is that when we run that pipeline again, you will see that the trained model is not overwritten, because we enabled the versioning of the data catalog. So you can see that we've got versioned true, and when we enable that flag, so it means that when we run that pipeline multiple times, we will have also multiple models. So each model will be versioned with the timestamp. So this is maybe some interesting thing, and that versioning is you need only that flag set for true to enable that versioning. So we just trained our first machine learning model in this step, and you can see it's not complicated, especially with the Kedro starter. Of course, you may build your own pipeline from scratch, but also when you work on like large organization or like even small company, you may create a template of the pipeline, like your private starter, and you may use it internally. It doesn't mean that it should be public. It's also like some additional benefit of using Kedro. So this was the lab number 1, and you may think, okay, we trained this on our laptop, but this is also the common problem of data science teams. But okay, it works easily on our laptops. That's true, because that was only the first part of the story. So now we would like to take that pipeline from our laptop and run it on some external computing environment. And here is our contribution to the open source community, because we at GetInData, we created a series of plugins which translates the local Kedro pipeline to be ready to run on multiple cloud providers. So you may easily translate your Kedro pipeline to run it on Kubeflow cluster, on Vertex AI, on Airflow on Kubernetes cluster, so it's not limited only to the Google Cloud Platform, but we've got like the generic open source options on Kubeflow and Airflow, and we are even not limited to the one cloud provider, because we support also the Azure ML. So you can write your pipeline using Python, and you may run it on the Azure ML service. And on our roadmap, there are also plugins to run it, plugins to translate the Kedro pipeline to Amazon Web Services and Amazon SageMaker. So this is our contribution. You may just take your Kedro pipeline and run it on the cloud environment. And at the end of the day, the result is that you may see the same, like the Kedro Vis diagram on your local environment. You may see the same thing running on the Vertex AI pipelines. Vertex AI pipelines is the serverless environment to run your machine learning models and training pipelines. It means that you send only the pipeline definition and the Docker container with this, and you don't care about any clusters updates, any Kubernetes cluster maintenance, and so on. You just you just send your input, and everything runs behind the scenes without the DevOps support needed. So this is the main benefit of the platform. It's the easiest one to start, so that's also why I decided to use it as an example for the workshop today. And yes, there is time for the second lab. There is another link on the same repository on GitHub. So you may also navigate to that exercise. And here, what we will do two things. First, we will prepare the pipeline to run on a Google Cloud Platform using Vertex AI, and we will actually run the pipeline using Vertex AI. Back to the code editor, and we can walk through the second step. Yes, so we've got local Kedro pipeline running on my local machine. Now I want to prepare this to run on the cloud environment. So yes, I mentioned the Kedro plugins. So we will need two things. So to the requirements file, we will add a Kedro Docker. This plugin will support us in creating the Docker container for our pipeline. And we will add Kedro Vertex AI, which is a plugin to translate our pipeline to be ready for Vertex AI. So we just added the two plugins. I will save the file, and then I need to install that plugins again. So I will just do the pip install here, and we need a few seconds to install. There we go. So that two plugins are ready. So now we need to create the default Docker container. So we will do Kedro Docker init. So it will initialize the Docker container. And you may observe that on the directory structure, it will, yes, the Docker files and the Docker ignore pops up. So first trick I will need to do is, because for the workshop, I will just use as an input to the machine learning model training, I will use the CSV file from the local file system. So I will need to add that CSV file to the Docker container. This is only for workshop purposes, because in real life scenario, you will read the data from some external storage. So we will define the proper paths on the data catalog. But for Docker, for the workshop, I will just simplify the scenario, and I will use my input data from the Docker container. So I will need to add the Docker ignore, because by default the data directory is ignored. So I will do the exception for the input data, and I will need to also update the base image for the Docker file from Python 3.6 to more modern Python 3.9. That's the preparation of the Docker file. Then we will need to update our data catalog, because we've got paths for the intermediate data set for the local file system, and because it's the serverless solution, so we don't have the common memory for that. So I will just comment out that path. So it means that it will take the files from the Docker container file system at the beginning, and then it will create like the staging bucket on Google Cloud Storage, which will contain that data in the bin format. So I don't want to serialize that data to the local file system of the pipeline nodes itself. So I will comment out that intermediate data. You've got the whole description of that thing also on the Markdown file, if you like to read more. So this is the second thing, is to adjust the data catalog, and then we would like to initialize the Vertex AI config file. So you can see that I did a command like Kedro Vertex AI init, and I provided the GCP project name, which is, you will replace it with your own, and I also give the GCP region here. So you can see that on the configuration and base, there is a new Vertex AI YAML file, and this is the description of your pipeline, how to run it on Vertex AI. So this is really important, and you need to do also a few adjustments. So first, you will need to give the actual Docker container name. So I will be building my Docker container, and I will store it on the Google Cloud Container Registry. So this is the gcr.io. So this is also my, I will add just the second, like the new Docker tag. So I will run that Docker container on my pipeline. And also I need to set the staging bucket. So here I need to set the GCS bucket. It's called, also it's my private one. So it's the MB temp and MLOps webinar demo. So this is the path of my Google Cloud Storage bucket. And now we are ready to build our Docker container. So here I will build my, my Docker container. So I will use the actual Docker tag. So I will build the Docker container and I will tag it with that tag. So here it's fast because I did a warm-up before the workshop, so I've got a cache for that container. So the build process is fast. On your side, for the first time, it can take up to 6-7 minutes. So now I've got a local copy of the Docker container, and in the next step, I need to push that Docker container to the container registry. So there we go. I will do Docker push, and I will need to also wait a few seconds to push that Docker container to the container registry. Also, it's fast because I've got something in cache. For you on the first time, it may take up to 10 minutes, depends on your internet connection. So now we built our container and we just send it to the container registry. And now there is a moment of truth. So when we've got the pipeline definition and the description in the YAML file, and we've got the Docker container ready, so we can schedule the pipeline for execution using the Kedro Vertex AI plugin. So the pipeline was just triggered for execution on Vertex AI. So we've got a link to the interface. And if there is no mistake on my side, I will switch the window. You will see the pipeline on the Vertex AI pipelines. So now it will take also a few minutes, so we will go back at the end to that step. So now the pipeline is triggered. Vertex AI pipelines pulls the Docker container, executes the pipeline steps, and move to the other pipeline steps. So actually, this is the same you've seen on the Kedro Vis. things. We may even click on the pipeline step, and you can see that this is from the data processing sub-pipeline, and the pipeline node is preprocessed companies node. This is the thing you just trigger for execution, and it will train a model, and it will save it on the Google Cloud Storage bucket. So let's give it some time to accomplish, but we will go back to the slides at this point. So you just scheduled your first machine learning pipeline to execute on the Vertex AI pipelines. Yes, now I would like to say a few words about the automation of that process, because you can see that, okay, we built everything manually, we even built Docker container locally, we pushed it manually to the container registry, and there was no version control, there was no GitHub repository, because it was only the laboratory example for the education. In real life, you will need more things, more building blocks to automate the process. And the ideal world will be that, like, data scientist will do some change in the pipeline definition, like the new feature will be added to the pipeline. You can push that changes to the code repository, and everything will happen automatically. For our clients, we propose something called MLOps platform. So this is the framework to unblock a few things on the machine learning model training process and the deployment process, because with that automation, we can democratize machine learning within the company, because we unblock data science teams to own the whole process, and there is no need to engage other teams. With the machine learning model pipeline concept, it also improves the time to market. You've got cost reduction, because you may leverage the serverless services, which means that you pay only for the resources you use. And you've got also like many more benefits, like built-in security, because when you set up your thing on cloud platform properly, it's secured, and there is no like public data exposed and so on. You can also like save a lot of time with the automation of the whole process. So how that framework looks like. So at the beginning, we've got a data scientist, and we've got the data. You might develop your model locally or on the Jupyter notebook. Then data scientist can push the changes on the pipeline source code to the code registry, and it triggers the training pipeline CI/CD, which is some service to build the Docker container with your pipeline. Then you push the Docker container to the registry. Then it triggers the continuous training. When the model is ready and is trained on the new data, the model can be saved on the model registry. We recommend MLflow in this case, and then you may set up your MLOps platform for automatically deploy that model for the serving application. And this is the generic framework which splits the whole process for the experimentation, training, and serving. And what's more important, it's not tied to one cloud provider, because we can build that framework on top of the open source tools. We can exchange that parts, and we are not bounded to one or two cloud providers, because currently we support and we build that MLOps platforms on Google Cloud Platform, AWS, Azure, or even like the private on-premises Kubernetes clusters. We've got also new features on our roadmap, which is the integrations with Databricks and Snowflake. So here is how it can look like on the real life, and using the automation of the steps we just performed manually. Before we do the Q&A, so let's see our pipeline progress. So we can see like that pipeline, 3 pipeline steps are created, and now it needs some more time to execute. So I think we are just at the right time to take a few questions from you. And if you've got more questions or your questions will came up like tomorrow or like after the webinar, you can send it also on the hello@getindata.com email address. Okay, so let's pick some questions. So I see one, like, what is the purpose of feature data layer? What are usual functions they create for this layer? So I think this is about the data layers in the Kedro framework. I will switch windows to the data catalog, because this is the place we can see this. There we go. So someone asked about the data layer. So data layer, we can see this on the 2 things. So we've got different layers of the data, and so this is the directory structure, just to make a space for the things you usually use on the machine learning projects. And you may keep your data files, like the input files or the intermediate data here, and you just assign that things you assign the layer of the data catalog you just defined. So we assigned the data catalog to the layer here, and this is mostly about the Kedro data model. So there is something like, I'm just checking the right thing on the documentation. There we go. There we go. So this is also, this question about the data layers is also on the Kedro. There we go. Kedro frequently asked questions, so you may read more. And there we go. So this is like the data engineering concept defined by Kedro engineers, and this is like the proposal of how the data, the input data, the output data, and the intermediate data sets are organized within the Kedro framework. So you may read about that layers here, and also there is like detailed description of each things behind of the data layer concept. So this is like the lecture for later. Practically is how to organize your data within your machine learning project, and this is the concept. You might just override this with your own, for example, or you may just don't want to use it too heavily. So this is about the data layers. Okay, let's take a few more. So the next question is Kedro open source tool? Yes, Kedro is an open source tool. Probably you may have some concerns, like who is the sponsor of that project and so on. So the history of this is that there was a British consulting company called Quantum Black, and it was acquired by McKinsey consulting company, and they are like the main sponsors and maintainers of Kedro. So also behind the scenes of Kedro being open source tool, there are also like big companies supporting the Kedro development, and you may check also the list of companies on the Kedro GitHub project page. You may see the list of Kedro companies which uses Kedro. So yes, there is our company there, GetInData. We've got also NASA and many different companies across the globe. So you may see that this tool is quite popular and well supported. And as it's open source tool, if you find some new feature to add or some bug to fix, you may also open your pull request and contribute. And let's make 2 more questions to test a pipeline. So there are different ways to create the tests, but for example, Kedro has at least one built-in option for tests. So I will go back to the code editor. So you can see that within the source code, we've got also dedicated space for tests. And Kedro behind the scenes uses the PyTest. And there is also like nice command to run that test. So there, if you run Kedro test, so it will run the PyTest on your pipeline code. So in this case, like there are some default tests prepared for you. So you can see like one test passed and it's okay. There are like built-in solutions to test the pipeline. You can also test your pipeline on some dummy data by creating the like dedicated environment. And generally speaking, in the commercial deployments, we usually make the Kedro test as a part of the build CI/CD pipeline. So before we deploy that pipeline to production, we may also make like check run Kedro tests in the pipeline as a CI/CD step. So you may break the CI/CD pipeline if the tests are not passing. So this is something. So generally speaking, there is an integration between Kedro and PyTest. And the last one, what about security? How it integrates with Vault and cloud integration? Yes. How about security? So we solve that thing on the MLOps platform. There are some security features because everything when running on cloud, there are like different security layers. And for example, you can create the service account with the right permissions to execute that pipeline. You may, with service account and IAM policies, you may just, for example, you may isolate your production environment just to only service account has access to some production environment deployments. Also, like the tests are part of the security. You may import, you may integrate with the secret manager, for example, to keep some credentials if you need it. So there is no credentials on the source code because, for example, you may read something on GCP from secret manager if you need something. But generally speaking, we rely on the service accounts and the right permissions there. And like under the hood, there is still Kubernetes cluster, so there is like low-level isolation of the resources, processes, and so on. So this is like regular cloud computing problem, and it's like well addressed within the software engineering techniques. We've got also like another layer of security, for example, the compliance part. And so you may define like, okay, you will not serialize the data which are like fragile and sensitive. So you may use memory data sets in Kedro, but this is maybe more broad cloud computing thing. Like you may specify like, okay, I'm from European Union and I don't want to my data to leave the European Union data centers. So we may also specify that things with cloud regions and cloud zones on the data processing places and storage. So yeah, there are like, this is like a really broad topic, but yes, we've got the same options here in this scenario, like running Kedro pipeline. We've got the same options like in the whole cloud computing. So maybe if there are like more questions and you like to discuss it, just I encourage you to send it to our email, and me or someone from our team can follow up on these questions. And yes, so let's check. Yay. it works. So the status of our pipeline is like all green. So that pipeline was executed on the Vertex AI pipelines, and just a few takeaways for you. So you may check out our recent MLOps ebook about building feature stores with Vertex AI, Snowflakes, and DBT. I invite you also to our blog, because if you are interested in more MLOps topics, there are like many good resources from my team published on the GetInData blog, including the one resource about running Kedro pipelines on the different cloud environments. So my colleague Marcin also prepared really good material about the Kedro plugins. And yes, the last thing I would like to ask you is to leave your feedback. So thanks a lot. And if you like to contact directly with me, here is my email. You may also use the generic one, like hello@getindata.com, and I recommend you to check out our blog and also our GitHub repository with where the Kedro Vertex AI plugins are available to check. So thanks a lot, and have a good day and good evening.